Simple harmonic motion. The objectives are to determine the spring constant of a spring by measuring the period of a mass spring system, and to use the Hooke's law equation to solve for the spring constant as well.
The materials are the video camera, motion sensor, masses, coil spring, tail ring stand, pendulum clamp, and C-clamp. The methods are as follows. First, use a C-clamp to secure the large ring stand. Then use the pendulum clamp to attach the spring so it hangs beyond the edge of the table. Place the motion sensor under the spring and adjust the rate to 10 Hz. Hang the masses from the spring at equilibrium and release. Make sure it extends at least 15 centimeters. Release the mass and record the data for the oscillating mass for 10 seconds and repeat previous step for the other two masses.
The table for the data from part 1 is shown. The equation for the spring constant is 4 times pi squared times mass over the period squared. For the 300 gram mass, the period was 0.77 seconds, and the calculated spring constant was 19.976 newtons per meter.
Here is the design system for Hooke's law, which was repeated for 3 different sets of masses. The table for the data from part 2 is shown.
The equation for Hooke's law is F equals negative kx, where x is the displacement of the spring from its point of equilibrium, k is the spring constant, and F is the restoring force. By finding the restoring force and the displacement, we can plot the results on a graph and solve for k. For the 200 gram mass, the displacement was 9.6 centimeters, and the calculated spring constant is 20.432 Newton meters. We used a graph to plot the remaining masses and found the slope to be 20 Newton meters.
We used Hooke's law, which we used to find the theoretical book value, to determine the percent error. Using the formula, we determined the percent error to be 2.34%. The spring constant may be determined using the formula that describes the relationship between the period and the spring constant of such a system. T equals 2 pi times the square root of m over k, or k equals 4 pi squared m over t squared. Additionally, Hooke's law can be used to determine the constant. The spring constant will be the same regardless of changing variables such as mass or period. Period will increase with mass increases, while the amplitude doesn't affect the oscillation of the mass spring system.